Let's talk about some vector operations, some ways that we can combine vectors into new things. So the vector operations that we need to be aware of are vector addition, scalar multiplication, and then we'll have vector multiplication. Vector multiplication comes in two varieties. The dot product and the cross product. Vector multiplication comes in two varieties, the dot product and the cross product. Important to note that the cross product only applies in three-dimensional space. So this is for three-dimensional space. So if we're going to restrict ourselves to two-dimensional space, we need to know about vector addition, scalar multiplication, and vector multiplication, specifically just the dot product. In vector addition, we take a vector plus a vector and come up with a vector. So this is just vector plus vector equals vector. It's combining two vectors to another vector into a third vector. Scalar multiplication is where we take a scalar and multiply it by a vector and come up with a vector. And in vector multiplication, for the dot product, we're going to take a vector times a vector and get a scalar. That's why we call it the scalar product. The reason that we call it a dot product is that the notation for this multiplication is a dot. So it's a vector dot vector equals scalar. That's to indicate what kind of multiplication we're doing. Now, the cross product we're not going to worry about because we're only going to restrict ourselves to two-dimensional space, but the cross product is a vector product, which means we will take a vector times a vector or vector cross vector and come up with another vector. But that's only a thing that we do in three-dimensional space, and we're going to concern ourselves with two-dimensional space today. All right, let's look at how we can do these operations. First, we'll talk about the easiest one, scalar multiplication. This is where we are changing the magnitude, but we are maintaining direction. When we multiply a vector by a scalar, we change the magnitude, but we keep the direction. So for example, if I've got a vector that is so if this vector v is equal to 4, 3, if I multiply this vector by 2, the scalar 2, I will double the magnitude of the vector. I just realized I wrote 2 right where I want to write my father. I'll do that symmetry. So if the vector v is 4, 3, if I multiply v by 2, the vector 2v if we multiply a vector by a scalar, all we do is multiply the components by that scalar. So if I ask you to multiply a vector by a scalar and didn't tell you how, just asked you to guess, that's what you probably would have guessed. This is our favorite thing in math, when what we would have guessed is what actually happened. So 2v is just going to be 8, 6. Note that we have made the vector longer, but we have not changed the direction of the vector. Another thing to note is that backwards and forwards counts as one direction. Backwards and forwards is not two directions, it's one direction. Backwards is just -1 times forwards. So if I have a vector -1 times v, that will be -4, -3. Backwards and forwards still only counts as one. Backwards is just -1 times forward. So we're not changing the line of the direction, we're just changing the length along that direction. We can also make things shorter, so like 0.5z. I didn't change the direction, we just changed the length. This is why we call it scalar multiplication. It just scales the vector to whatever length we want. That's operation, the first operation that we learned about with vectors. The second operation that we want to know about with vectors is vector addition. This is where we are combining the directions. So for this, we need two different vectors, or two the same vector. We need two vectors. So let's say V is the vector 4, 3, and let's say that the vector U is the vector -2, -2, 1, 2. If we combine these two vectors, we just do one of the directions and then we do the other direction for when we finish the first one. We just combine the directions. So U plus V, I start off, I draw a U, the U vector. And then at the end of the U vector, I place the V vector. And then start to finish, that's the vector U plus V. We're just combining the directions. So there's the vector U plus V. Note that this is the same vector that we would get if I added them in the other direction. If I first did the vector V and then did the vector U, we would draw the same resultant vector. So if I did the vector V, and then did the vector U, we end up at the same place. So U plus V will be the same as V plus U. We can do this in components as well. We don't have to just visualize everything. If I want the vector U plus V, I just take my U vector, -2, 5, and add the V vector. And we do exactly what we would guess. add the corresponding components. -2 plus 4 is 2. 5 plus 3 is 8. So that's this u plus v, v plus u vector, or u plus v. It's 2 and then 8. When we do vector addition, we are combining the directions. Any questions? Is everybody okay? When we use scalar multiplication and vector addition to combine vectors, we are making what's called a linear combination. So we say a linear combination of vectors is when we just make a combination using scalar multiplication and vector addition. That's what we get when that's what we call a linear combination. So for example, 2u minus 3v is a linear combination of vectors. So I'm using scalar multiplication and then vector addition. So 2 times -2, 5 is -4, 10. -3 times 4 is -12. -3 times 3 is -9. -4 minus 12 is -16. 10 minus 9 is 1. So that's 16, -16, 1 is a linear combination of u and v. Making linear combinations, we're just combining things exactly and doing the operation exactly how we think it should work. Any question? Comment? Slide along. How's everybody okay? All right, that's going to do it for today. This weekend is, well, we got a holiday week, so there's no class for the rest of the week, but there aren't normally no classes for the rest of the week for us, so we don't really see it. So I hope you all have a nice Thanksgiving. If you are seeing family, I hope you enjoy your family. If you're avoiding family, I hope you successfully avoid your family. That's going to do it for today. Everybody have a nice long weekend, and I will see you on Monday.